thin rod it is. So the axis of rotation is now I'm going to rotate. I'm just showing for your understanding purpose that arrow. What do you mean by that arrow? It is rotating about that axis here. What is the mass? Let L be the length of the rod. And let m be the mass of the rod. What is the moment of inertia of this rod about an axis passing through its one end and perpendicular to length? So where the rod is lying along x-axis. So I think it will be easy for us. And this is y-axis. So what is the here? Moment of inertia about y-axis, no? And how the rod is lying along x-axis. It's a thin rod. If it's a thick rod, it will become cylinder. Thin rod are like refill, better. The refill which is there inside the pen, that you can call like, almost you can take like a thin rod. How to calculate moment of inertia? What we know, only moment of inertia for a particle. So therefore what I'll assume is, let me assume a strip of length dx at a distance x. What is the mass of this dm? Then the formula will be dm is equal to lambda into dx. What is lambda? Mass per unit length. Then this particle is at a distance x from the axis. Then the moment of inertia of this elemental particle dm into x square. So what is the dm? Lambda into dx. So lambda x square dx. Where all mass is spreaded from x equal to 0 to x equal to L is what the mass is spreaded. So therefore the limit will be 0 to L. So lambda L cube by 3. Further, what is lambda? Lambda is m by L. So shall I put y dash, the axis, about y-axis? So what is this moment of inertia of the rod about an axis passing through one end and perpendicular to length? See, like I'll suggest you, it's a really mass-based one. Somewhere around 40 or 50 numericals are there of different shape. Yes, you must know, but in exams, nobody will ask you, not weekend, final exams, when you go for advanced or mains, nobody will ask you find moment of inertia of cone because already you know it. It's a formula. So just put some effort for different types of rigid bodies, how to calculate moment of inertia. You must know that mathematics involved. And for exam, what you should not practice such things because nobody will ask you any formula based in advance. So definitely what you should know for different shaped objects, what is the moment of inertia about different axes? If you know this, then based on this, application problems will come. But initial a student must know how to calculate moment of inertia. Under different, like center of mass, how to calculate center of mass, how you worked out, no? Similarly, you have to put effort here. You have to take help of integration. This is about moment of inertia about axis here. So let's take this is a thin rod, no? The same thin rod about an axis passing through its midpoint or about center of mass. Now where the axis I'm going to bring exactly at the center, that one. So this length is L by 2. This length is L by 2. Then what is the moment of inertia about? Axis passing through its center of mass and perpendicular to its length. I'll assume here one element at a distance x. Shall I assume one more symmetrical element? Because there's a symmetric distribution of mass is there. Two symmetric elements we assumed it. Then from this, what is the moment of inertia? So we know di is equal to dm into x square, dm into x square. Why twice? Because two elements are there. Sir, how you can go back to the particle? First one particle we started mx square, then four particles m1x square plus m2x square plus m3x square plus m4x square. The similarly same thing here. So this will become 2 dm x square. So what is the limit for x? X will be x equal to 0 to x equal to L by 2. This side the distance will be x equal to minus L by 2. So further lambda dm will be lambda dx x square. So this will be 2 lambda x square dx. What should be the limit? What should be the limit? Limit should be 0 to L by 2. The reason for that, I assume two elements. Not 0 to L. Because I assume two elements, no? So therefore 0 to L by 2 will come. If you solve this, will end up this. I dash equal to ml square by 12. Sir, I'll assume only one element. If I assume one element, then what should be the limit? Minus L by 2 to plus L by 2. I think there's a basic integration what you should follow here. So we can also write this as di is equal to dmx square. Then further lambda dx x square. Or this di is equal to minus L by 2 to plus L by 2. Both will be same, you'll get same answer. Both you are going to get the same answer. So solve it, substitute here. So we are not getting this 0 to L by 2. I assume two symmetric elements. Then in the same way, the mass is getting distributed on either side of the midpoint of the rod. I assume two symmetric elements. So 2 into dmx square. Then the limit should be 0 to L by 2. If I assume only, sir, I'll assume only one element, then x will vary from 0 to L by 2 and also 0 to minus L by 2. So therefore, this will be minus L by 2 to plus L by 2. You'll get same answer. Again, no need to bother here. When to assume two elements, when to assume one element. When to two elements, when to assume one element. It's all about the how the mass is distributed symmetrically. If it's distributed symmetrically about an axis, you can assume symmetric elements and you can simplify the mathematics here. So if the mass is not distributed symmetrically, then you are going to assume only one element. So this particular application you can see more in electricity magnetism than here. And now, still, sir, what is moment of inertia? I think definitely most of you now will be holding pencil or pen. No, try to revolve. Try to rotate that pen or pencil like this. Huh? Now try to do like this. At the midpoint, you try to hold and try to rotate. Then at the end, you try to hold and try to rotate. Where you find, so it'll be like this. Huh? At the end. Then at the midpoint, try to and rotate it. Or it'll be much easier. Huh? So it'll be like this. Then where you feel a little bit easy to rotate, where you feel. So this is something very important. Huh? So like that, you take notebook. Not on this. Let's take notebook here. Now next here, this one. Then this. Then like this. So definitely as the rigid body, if I try to rotate about different axes, I find little bit the difficulty what pen will be different in different axis of rotation. The reason for that, the moment of inertia will be different about different axis of rotation. So any reason for that? So now let's go back to again the basic definition. This mi depends on what all? You can see that mi moment of inertia depends on mass of system and distribution of mass about the axis. The moment of inertia of the system depends on what? What is the total mass of system? The next, distribution of mass about axis, about which it is rotating. Now look at this. Earlier the axis was about 1 inch. So L square by 3 came. Then axis passing through center of mass. Then L square by 12. So therefore, the moment of inertia depends upon the mass of system and also distribution of mass about the axis. There is a reason why the same though. So what happened? The same body. What happened when I start rotating about different axes? No, here I'll feel different rotational effect. The reason for that, the moment of inertia depends upon the axis of rotation. You can see this rod itself about one end about center of mass. The moment of inertia is different here. So let's take one more. The same for rod only. No, this is the axis. No, this is a rod. It's a rod actually. No. What is this dotted line? Dotted line will is called as axis. I'm going to rotate here now. The rod is having mass m. It's having a length l. It's a thin rod. Thin rod. I'm rotating about an axis. Take example refill, and you're trying to spin the refill about its axis parallel to its length and passing through its center. Then what is the moment of inertia? So what is the distribution of mass? So almost all the mass is at the axis, because here to make it visible, I'm showing some distance of the mass here. But practically what will happen? The whole this mass will be at the axis. Then what is the basic moment of inertia of definition? Di is equal to dm into x square. So what is x here? Will be 0. So what is the moment of inertia? Will be 0. That one practically it will be negligible, because you take however thin it may be, you take refill. So you say that there's a refill, sir. Then there'll be some mass present here. No, I'm talking about the ideal thin rod. So where the mass of the rod will be along the axis here. To make it visible, I'm showing some mass at a distance from the axis here. So if I say x equal to 0, very thin rod, then here definitely what you can say, no, moment of inertia is negligible, no, or you can better say 0. So what is the moment of inertia of the rod about an axis which is parallel to its length or passing through its center? About an axis passing through its center and parallel to its length will be 0. That one able to understand, no? So the moment of inertia depends on what? Depends on distribution of mass also. You take the same pin. Now it will be much easier for you to rotate. This will be much easier to rotate, you can see, than this one. Any reason for that? Any reason for that? Because moment of inertia will become negligible in this case. In this case, yes, it will have some moment of inertia. What about this case? It will have some moment of inertia. Getting that one? So therefore, definitely the moment of inertia plays very important role. That one. The inertia, the rotational inertia depends on axis of rotation also. Moment of inertia is 0, let it be 0. What is the problem with that? Very easy to rotate. Moment of inertia negligible means very small, means very easy to rotate. Alpha equal to torque by I. Torque is a fixed quantity. If moment of inertia decreases, then alpha will be more, no? So if moment of inertia is less, it will be very easy to have, for a given torque, I can get more angular acceleration. This is the meaning of that. And now let's take the further. Suppose that this is the axis here. This is a rod. Now, what is the moment of inertia? There is a rod of length L, mass M, length L. It is at a distance x here. Now this is the axis here. Now, how did it rotate? It will go around in circular path. What is the meaning of that? Suppose if this is the axis, the other rod will go around like this. So this is the rod now. This is the axis. Or so this my finger is the axis. Now the rod will go around. The pen, no, pen is a rod now. So it's going to go around this one. It's revolving around this. Then what is the moment of inertia of this rigid body? Now where is the axis? Axis is not passing through the center of mass of the pin. It'll be like this. Able to see now. What is the moment of inertia? So this will be again where the whole mass of the rod. I'll assume all small elements. I'll assume a small element. At what distance the small element is at a distance x, so what is di is equal to dm into x square. Then look at all the elements, all the elements they are at same distance. So therefore, what is the total moment of inertia? X square is a common integral of dm. So what about the total mass of the rod? 0 to m. And this side it will be I is equal to x square into m. Mx square. It doesn't depend on its length. Because all the points on the rod at a distance x only. So therefore, so it should be x square integral of dm. What is the total mass of the rod? It is equal to m. So mx square. So this is the moment of inertia about this axis. So small basic ideas are very important in numericals when we go for it. Okay, this is about the rod. So okay, let's take the first one, parallax theorem I'll introduce.